All right, this is lesson 6.2. This is our third video. There's actually going to be a fourth video as well. Like I said, this is going to take us a few days to get through this. But I want to show you one more quadratic where it factors somewhat nicely. Then we'll do some powers, and then we'll do a quadratic where it does not factor nicely. You want to use your quadratic formula. That'll be in the next video. Don't worry about that in this one. Okay, negative 2 sine squared x equals 3 sine x plus 1. I notice I've got a quadratic. I've got that second power. Also have a linear term, sine to the first power. So I want to set this equal to 0. I have a negative 2 sine squared. I think I'll add that to the other side. And so I'll add 2 sine squared to both sides. So I'll go 2 sine squared of x plus a 3 sine of x plus a 1, and that whole thing equals 0. Okay, how do you factor when your leading coefficient here is a 2? Well, then you take that 2 times the last one, the 1, and 2 times 1 is 2. And you break up the 2, and how do I get 2? 1 times 2, negative 1 times negative 2. I'll go with 1 times 2 because I add that up, and that gives me the 3. So if you forgot how you factor that way, certainly you can ask it in class as well, but I get 2 sine squared of x, and I've got my 1 and 2, so I'll go plus 1 sine x plus 2 sine x plus 1. Look at the first two terms. What do they have in common? They've got a sine of x in common. Factor it out. So sine of x times 2 sine x plus 1. What do the last two have in common? Nothing. So bring out a 1. I get 2 sine x plus 1. Now notice they both have 2 sine x plus 1 in common. Pull that out in front. 2 sine x plus 1. What was left? Sine x here. 1 here. And that whole thing equals 0. So how do I solve this? Well, either the first one equals 0, meaning 2 sine x is negative 1, meaning sine x is negative 1/2, or the second one equals 0, meaning sine x plus 1 equals 0, meaning sine x equals negative 1. Look in the unit circle. Where does the sine, let's do negative 1 first, that's easier. That's the y-coordinate. Where's the sine negative 1? Look in your unit circle. You should notice at 3 pi halves. Second one, where's the sine negative 1/2? You're looking in the third or the fourth quadrant. Sine is the y-coordinate, so are you thinking 7 pi 6 and 11 pi 6? So it was a quadratic. We could have gotten 4 answers. We only got 3 because, again, that 1 or that negative 1 only gives us 1 answer. So 3 solutions to this: 7 pi 6, 11 pi 6, and 3 pi halves. Okay, I'm going to go slightly out of order here, but it'll be okay. We're saving the most difficult problem for the end. So come back to our algebra examples here. I'm going to let this one go for right now, the quadratic equation, part 3. That'll be the quadratic formula. And let's look at this. How do you handle an algebra equation with powers bigger than 2? Linear equations, you got the variable on one side, got the numbers on the other side. Quadratics, you set it equal to 0. So how do you handle powers bigger than 2? And the answer is just like a quadratic, set it equal to 0. So I've got 2x to the 4th, I'll minus x squared, that equals 0. I'll see what do they have in common. I'll factor out that x squared, and I get 2x squared minus 1 equals 0. And then basically I can set the first term equal to 0, or the second term equal to 0. Here, if I take the square root, I get plus or minus 0. No big deal. Here I'll go 2x squared equals 1. X squared equals 1/2. So x equals plus or minus the square root of 1/2. And I know I don't leave that like that. Square root of 1, I don't know. Square root of 2 is down there. There's a plus or minus, and you know to rationalize. So I get plus or minus root 2 over 2. Had that been my problem. Okay, now let's look at a trig one with a power bigger than 2. So again, in this time it's in order on our trig sheet here. We've done all this. Let's look at this. Very similar question. 2 sine to the 4th x equals sine squared, set it equal to 0. So 2 sine to the 4th of x minus sine squared of x equals 0. All right, GCF, what do they have in common? They have a sine squared in common. Bring that out. Here's a 2 sine squared of x, that was left, minus 1 equals 0. Set the first part equal to 0. Sine squared of x equals 0. Set the second part equal to 0. 2 sine squared of x minus 1 equals 0. First one, solve this, take the square root of both sides. So sine of x equals 0. Second one, add on 1. Divide by 2. And this is like the problem we just did. Take the square root. And don't forget plus or minus. Square root of 1, I don't know. I'm sorry, square root of 1, I know it's 1. Square root of 2, I don't know. I'll rationalize this. I'll get square root of 2 over 2. Okay, last thing, look at your unit circle. Where does the sine equal 0? Sine was the y-coordinate. So at 0 radians or pi radians, you could maybe try to sneak in a 2 pi, but usually it does, 0 is the same thing as 2 pi, so we've said it was 0. And where's sine, oh my goodness, plus or minus root 2? So positive root 2 would be pi fourths and 3 pi fourths. So if you look at a unit circle, if you don't see these, minus root 2 over 2, 5 pi fourths, 7 pi fourths. And again, hopefully this kind of goes with what you're expecting a little bit. It was a fourth power. We could have gotten as many as 8 answers. Why did we only get 6? Because look right here, we had the sine squared equals 0, and that only gave us 2 answers. Potentially that sine squared could have given us 4, but since it equals 0, it only gave us those 2 answers. So that is how you handle powers bigger than 2. Just like powers equal to 2, set them equal to 0. Okay, only one thing left. What happens? Actually, 2 things, but one big thing left. What happens when you can't factor? And that will be the last video.